Good day. This presentation is a geotechnical desktop study of a new industrial development in Swartkop, Pretoria. The purpose of the desktop study is to find whether the site chosen is, or rather has, suitable conditions for the new industrial development to be constructed there, and also keeping in mind that a basement 6 meters underground has to be constructed. So whether the site is strong enough, or the soil conditions on the site is strong enough to withhold that. And then the documents I've used was the geotechnical study guide, Google Maps and Google Earth imagery for my figures, as well as the South African pavement engineering manual. So, a general site description. The site is filled with lots of grass, sand, and trees. The amount of greenery can be seen in the image right next to that. Also, there are two class 3 roads surrounding the site, and the R55 is quite busy, so it makes sense for an industrial area to be there, since many heavy vehicles make use of that road. Then, in terms of climate, the area has a moderate rainfall, with a Y0 in value of between 2 and 5. And topography, the site is relatively flat, but towards the Henops River on top there, it slopes up with a gradual slope first and then a steep incline, as we have the military base there, as well as a mountain not far from the site. Then field and laboratory proposal. So since we are investigating whether the site is suitable for the development, a test needs to be done on the soil conditions so that we can see which properties it has, and then determine whether the development can be built, as well as which measures can be implemented to improve on the soil conditions. So some of the field and lab work that has to be done is undrained shear strength, permeability, collapse, heave, the description of the soil profile, as well as the consistency of the soil profile. Also, health and safety is really important. So therefore, I've looked at some guidelines, or rather two health and safety guidelines that could be made use for when construction of the site has to be implemented or taking place. I made use of the Occupational Health and Safety Act, and some of the regulations are the risk assessment for construction, the fall protection, structures, excavation, scaffolding cranes, construction vehicles, and plant mobile. Then the other document that I used was SABITA, Health and Safety Guideline, and in there it talks about the regulatory requirements, as well as general considerations for lab work and the hazards surrounding that. Then for stormwater drainage, I've decided to go along with connecting the new stormwater drainage to the existing stormwater drainage. So just draining it off on the sides of the property, as well as connecting the new drainage to run off into the river. Since it can be seen that since the mountain then slopes in that way, that it's just natural for water to be flowing into the river and then just being carried away. For geology, As shown in the picture in front of us, we can see that the soil conditions are mostly sandy clay soil conditions. This bringing up problem soils like soft soils and collapsible soils, which can be a problem for when you are excavating, especially during rain seasons, because that then leaves this sorry, that then leaves the soil unstable because of the water content in the soil. And then for rocks, we have sedimentary rocks under the soil, underground, since or rather due to all the water seeping into the ground, because clay material tends to hold quite a bit of moisture content in them. For site excavations, it is really important that proper measures are taken and that they use proper reinforcement while doing the excavations, so that we have no soil falling into the trenches while they are digging and so forth. So the following essential components need to be taken into consideration: the excavatability of substances and the hydrological solutions, as well as the stability of the sidewalls, slopes, as I've just mentioned. And then selected secondary concerns additionally consist of the following: bulking factor of material excavated for earthworks, the durability of the material, as well as the deformation of the ground. Main material sources: there are 3 quarries surrounding or rather close by to the site location. Therefore, any necessary materials such as sand or rock or whatever else may be needed for the construction of the site could be acquired there. But if not, and then they would then have to import or get that from outsources for doing for those jobs. Environmental considerations: the influences that the geological processes will have on the environment is the uplift and substance, which is the monitoring and control measurements; erosion of sedimentary, the increased risk of flooding and landslides or damage to populations and infrastructure; then the changes in the water table, which is any problems in your foundation, effects on crops and irrigation and draining measures as well; and then your geochemical processes, which are hazards of gas explosions or difficulties during tunnel construction. Then, in conclusion, it has been established that the geological properties of the site is sandy and clay, and also it holds quite a high or moderate high moisture content. Therefore, the site isn't quite as suitable for the industrial development, but we can make use of the site for industrial with the proper parameters and reinforcement put into place, which comes to my last slide, which is recommendations. So for recommendations, I recommend retaining walls for the basement to prevent the building from collapsing in due to all the external forces and pressures pushed inwards on the building. Then reinforcement in foundation, since the soil has a high moisture content, reinforcing the foundation and the concrete would then allow for the building to have less settlement, so not that much movement of the building structure. And then, as I've previously mentioned, that for the stormwater to be tied into the existing drainage system. And I hope that you found this insightful, and thank you very much.